Hello, let's move on to the next lesson. And the next lesson is going to present us with a potential problem. And then we'll look at the solution that some cells have. And we have one of the solutions. And athletes, you and anybody who works out, you know the problem. The problem is if you are working out and you have reached the end of your endurance and you are breathing deeply and you just can't provide enough oxygen for your muscles. You know that your muscles just are burning, and that is the problem that we want to look at. And that would be when we just don't have a lot of endurance and we just can't provide oxygen. So, what is the problem if we can't provide enough oxygen? And it has to do with the fact that oxygen is at the end of our chain. And the reason I asked you to think about an assembly line, what happens in our assembly line if the last step isn't there? And I hope you kind of think about that. Everything starts backing up. And that becomes a problem because if you have an assembly line that is supposed to be accomplishing something, and the last step isn't there, then you're not accomplishing that. And so here's why this is a problem. So let's take a look at this in detail. Oxygen is our last step in our electron transport chain. It's the dumping ground of that electron. It would go to that oxygen, get converted to water. That's where our water comes from in cell respiration. Now, if that oxygen is not there, then guess what? This guy can't dump its electron off. And if this guy can't dump its electron off, guess what? This little electron can't be passed on. And if this electron can't be passed on, neither can this electron. It can't be passed on. And so forth, and so forth, and so on, and so on, and so on. And everything backs up. So, am I obvious enough here? Stop, stop, stop. So if oxygen is not there, then every single one of these molecules just stops in its tracks. It can't pass the electron on. And again, think about an assembly line. Think about a really smooth factory assembly line. But if something stops at the end, everybody stops before that. And so much so that even NADH, remember, we've got this huge convoy of NADH and FADH2 molecules. And if they can't dump, then they're just sitting there with their electrons. They're not going to dump if they don't have a place to dump their electrons. So here's the problem. Oxygen is the dumping site for electrons. Everything backs up, including NADH. And if NADH can't return empty, then the electron transport system stops. Remember, the electron transport chain, let me go back here. The electron transport chain is only able to pick up electrons from glucose and pyruvate, and if it's empty. So if NADH isn't empty, then we got a problem. And so everything would stop. The electron transport system stops, Krebs cycle stops, and eventually glycolysis would stop. And that's our last chance to get ATP. So there's no hope for electron transport system because if there's no oxygen, it stops. And there's not much hope for the Krebs cycle because if it can't empty its NADH, then it stops. But we can keep glycolysis. Remember, glycolysis is way out in the cytoplasm, and so it can keep working. So this will be a nice way to review as well, because we can go back to glycolysis. And so remember, glycolysis, let's look at the picture first. Glycolysis takes glucose and breaks it apart into 2 pyruvate. We get 2 ATP net, yay, and we also get 2 NADH. Now, that could be a potential problem because remember, NADH would normally go to the electron transport system. But if it can't, then it's stuck. But here's what some clever cells do. In our muscle cells and some bacteria, what they will do is they will dump their NADH electrons back into pyruvate, and that will turn it to lactic acid. Now this says lactate, don't worry, same thing. Now, lactic acid is what causes your muscles to burn when you're really exercising hard. You're lifting weights and you got that weight lifted, and oh, it's starting to burn. Or you've got your arm raised in class and the teacher's on a roll and the teacher doesn't see your hand up and your arm starts burning because you got your arm up. And then what do? You switch to the other arm. Well, that's lactic acid fermentation. You're not providing the oxygen that you need. So the point behind lactic acid fermentation is you will only be able to do glycolysis, and then continue. Uh, you'll be able to continue though producing ATP. You will only be getting 2 ATP, but that allows you to keep going. You'll at least not die, right? Lactic acid fermentation. And so here's that fermentation part where we're changing it to lactic acid. So bottom line, this is happening without oxygen. You're going to produce lactic acid that happens in our muscle cells. We only get 2 ATP, but at the very least, we can still go without oxygen. So that's lactic acid fermentation. We're producing lactic acid. Now, there's another fermentation process made by yeast cells. Yeast cells are going to undergo a similar situation. Without oxygen, they can't continue with cell respiration, but they can get rid of their electrons in NADH by dumping it back into, I say pyruvate, but technically it's acetaldehyde, but don't worry about it. It dumps NADH back in, and we get an ethanol, which is what breweries make for alcoholic beverages. Ethanol, same thing when bread rises, and we're producing carbon dioxide. So yeast cells can do alcoholic fermentation where they can continue to undergo glycolysis, still get 2 ATP from this process, but we're still able to continue doing it because we can get rid of the NADH and still recycle it. So again, the problem comes when we don't have oxygen. That means the electron transport system stops. That means the Krebs cycle stops. If we didn't have fermentation, glycolysis would even stop. But we can continue on with fermentation and still at least get our 2 ATP. And that's what's so helpful and so powerful for us. Not the fastest, not the most efficient process, but it does allow us to continue. And it is faster. So athletes, the first thing that you do when you start exercising, you actually do glycolysis, but you don't do lactic acid fermentation unless you're not providing enough oxygen. Yeast, when if you make bread or pizza dough, that's what your yeast cells are doing if they don't have enough oxygen, but they still produce carbon dioxide. So that is our last little bit, and we're going to do some practice problems to help us really kind of sink our teeth into all of these things. So happy practicing.